This lesson is for Advanced Algebra 6-1 on quadratics. A quadratic expression is any expression that is being raised to the second power, sometimes also called degree 2. So I have some examples here. This first one is kind of the standard form that we use for any quadratic equation or expression. So we've got ax squared plus bx plus c. All quadratic expressions can be put into this form. Know that not all the pieces need to be there, but the x squared has to be there in order for it to be considered a quadratic. So just a regular x squared plus another variable squared, those are still considered quadratic. Even if there's other pieces there, if the top exponent is a 2, and that's the largest exponent you see in the expression, then it is considered a quadratic. As soon as there's a power that's larger than 3, then it's not considered a quadratic any longer. Also, if something doesn't have a square in it, so 3x doesn't have a square, so that's also not a quadratic. Keep in mind that a quadratic is the name of the equation. When you graph a quadratic, you get a U-shaped graph, which is called a parabola. So the parabola is the name we give the graph. Quadratic is the name of the equation that gives that as its graph. It's very important that when you do a quadratic that you put it in standard form. We've talked about standard form before. Standard form for a linear equation was ax plus by equals c. Standard form for a quadratic is the one that we just talked about. Ax squared plus bx plus c. That's standard form for a quadratic. Be careful too that when you do standard form, you always want to make sure to put the highest exponent first, then any other plain variables, and then any plain numbers at the very end. When you're dealing with multiple letters in your expression, make sure you put them in alphabetical order as well. We're going to talk more about standard form later on and throughout the chapter. FOIL is another thing that tends to happen a lot when we're working with quadratics. FOIL is an acronym that students use to help them remember how to multiply binomials. A binomial is an expression that has two pieces in it, so we're going to be multiplying binomials together. So here I've just listed a very generic one. A plus b is the first binomial, c plus d is the second binomial, and we're going to multiply those together. When I do the F of FOIL, that stands for firsts, meaning the first term in the first expression times the first term in the second expression. So when I multiply A times C, I can just stick those right next to each other. So AC is the result. When I do the O in FOIL, that represents outsides or outer terms. So the outer terms here are the A and the D. So A times D is AD. The inside terms, or the inner ones, are B and C. So B times C is BC. And then the last terms, the only other thing that we haven't combined, B times D is BD. In between each of those multiplications we put a plus, unless there were some negatives in there that we need to incorporate. That's the basics of FOIL. I know students have seen it before, so hopefully that was a good refresher for you. Most of the time when we do FOIL, there's going to be numbers and letters mixed together. So let's go ahead and practice a few of these. I believe these are numbered the way they are because they do come from the homework. So I believe this is question number 6 in your homework, and usually the directions here will say to multiply or expand. So we're going to just do basic FOIL here. So I'm going to do the firsts, which is x times x, which is x squared. Outsides, which is x times 2, which is 2x. Insides, which is negative 3 times x, which is negative 3x. And the lasts, which is negative 3 times 2, which is negative 6. Be careful here, oftentimes students will neglect to multiply here and they'll say negative 5 by mistake and they'll think that they're adding. In each case you are doing multiply, 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 multiply. Each of these is a product. When you're all done, you want to look for like terms. Usually, not always, but usually the like terms are the two terms that are in the middle. The like terms are the terms that have the same variables with the same number of powers. So x squared is not a like term with 2x, but 2x is a like term with negative 3x. So now we're switching from multiplication like we did in step number 1, and we're turning to addition. So when you add like terms, you just add the coefficients, the numbers in front of the variable. So I get negative x and then minus 6. Let's try another FOIL question. 1 times 2 is 2. 1 times negative 3y is negative 3y. Negative 2y times 2 is negative 4y. It doesn't matter that those are not like terms. We're multiplying and we don't need to worry about that. Negative 2y times negative 3y is positive 6y squared. Now if I look for like terms, I do see some like terms here in the middle. So I get 2 minus 7y plus 6y squared. The problem is this is not in standard form. Standard form should have the highest exponent first and then in descending order after that. So I literally just need to rearrange this polynomial. It's 6y squared minus 7y plus 2. Could also say plus negative 7y there. So when you're working through a problem using FOIL, make sure you always write your answer in standard form. There is a shortcut to FOIL called the binomial square theorem, and it's not something that students must use, it's just another tool that students can use when the binomials are the same. So if you're multiplying x plus y or another equivalent binomial times itself, you can write out the binomial twice and do FOIL, but it's faster for you to memorize the binomial square theorem. The binomial square theorem says just take the beginning term and square it. That's your x squared here. Take the ending term and square that. That's the y squared term here. And then in the middle, we'll get a yx and then another yx. Those get added together because they're like terms. So you get 2xy or yx in the middle. The only change that's made if there's a negative sign in between the two terms is that the sign on the minus 2xy will be there as opposed to being a plus on the previous. So let's try these next two using the binomial square theorem instead of using FOIL. If students would prefer to use FOIL, they're welcome to do that. Just make sure that you are not saying here that it's simply d squared minus 6 squared. The 2 does not distribute. The 2 would distribute if it were a regular number in front. Powers do not distribute. So if you wanted to do FOIL, you would write out d minus 6 times itself and you would do FOIL there. I'm going to use the binomial square theorem instead. Take the first term and square it, leave some space, take the second term and square it. Negative 6 times itself is 36. In the middle, I'm going to take these two pieces and multiply them together. Since it is a negative sign, I know I'm going to have a negative result. And I know d times 6 is 6d, and then I need to double that. So that's going to be a 12d. So there I got my answer much more quickly than having to work through all the steps of FOIL. So again, you just take the first term and square it, last term and square it, the two terms that you have multiplied together and doubled, and then just pay attention to the sign that you're given. So let's try that one more time with number 11 in the homework. I take the first term and square it, leave some space, take the last term and square it. In the middle, I take the two terms and multiply them together and double them. P times W is just PW, doubled is 2PW. There's no negative sign here, so I make it all plus. Isn't that super slick? Makes multiplying binomials that are the same super easy. So I'd like you to pause the video right now and try these two on your own. 14 is a little bit more challenging because it has a fraction in it. Know that you don't need to worry about adding like terms here, adding a common denominator here because you are multiplying. You don't need a common denominator when you're multiplying. So try 14 and 15 right now and pause the video. Now that you've completed those two, up top here on each of these I've shown the FOIL method, which is one option you can take. On the second version of each of these I showed the binomial square theorem instead. Know that in both cases I got the same answer. Next, they talk about rectangles. And if you want further information, you can look at the book at example 2, page 375. A lot of times when you're working with a binomial, it's nice to visualize it in rectangle form. So I'm going to draw a rectangle. Doesn't matter what size it is. Doesn't have to be perfect. And I'm going to divide one of the lengths into two pieces called x and y. So the distance from here to here is x. The distance from here to here is y. So if I were trying to find the total length, I would not multiply them together, I would add. Think about it like numbers. If this length was a 4 and that length was a 2, would you get 6 or 8 for the total? You'd get 6. 4 for this, 2 for that, makes a total of 6. So if we were talking about making the area of this, or the total length, we would say x plus y. Let's do the same thing going the other way. So this is x, this is y. So the length of both sides of the rectangle are going to be x plus y and x plus y. So I guess I should have made it square instead of a rectangle. But let's just pretend. So I've got x plus y twice. But the nice thing about this rectangle is I can utilize the individual rectangles to help illustrate the different pieces of foil. So right here I've got a x times a y to get this area. So it's just going to be xy. Over here I'm going to have y squared. Over here it's going to be y times x, so that's another xy up there. And here I've got x times x is x squared. So now you've got your 4 pieces. Those would be the 4 pieces that you'd get if you had done FOIL on this expression here. So now let's talk about how to write that answer in standard form. Start with the first variable in terms of alphabetically which way would come first. So that would be x squared. Then any other x's should come next. So I've got an xy plus another xy should be 2xy. And then the y's have been introduced, so now those can go in reverse order. So I can put the y squared at the end. A lot of times kids will want to put x squared and then the y squared right away, and then you've got the xy at the end. This is not what I would prefer, and it's typically not what we would write for standard form. We like to do one variable at the beginning and keep that variable going in descending order until it's finished. So the one on the left here is preferred. X squared has been mentioned first. All the other x terms need to be listed before any other square terms. What's actually nice about the way this is lined up is that the x's are in descending order and the y's are in ascending order, and that's a very nicely organized equation. There are some questions in the homework that ask you to expand using your CAS calculator. I would like to just recommend that you only use the expand command when you are checking your answers. There will never be a situation where I will give you a CAS and ask you to use the expand command. Every time you're asked to expand in a question, you will have to do it by hand, either using the binomial square theorem or the rectangle picture or the FOIL method. So expansion on your CAS will only be used for checking. You will always have to expand by hand on tests and quizzes. If you would like further challenge for today, there will be a ticket out the door, which are problems 5 and 8. Students are welcome to try these 2 problems now. Try to do them without referencing your notes, and the answers will be displayed shortly.